Today's objective. I can add and subtract real numbers. Let's read it together. 1, 2, 3. I can add and subtract real numbers. Copy that at the bottom left of your Cornell notes, please. If you have color code it. And the question for me to you would be, what is the concept for today? Concept for today. Think about it. All right. Turn to your neighbor, let them know what is the concept for today. Okay, and what are we doing with it? We're adding and subtracting. So now we already know each piece, and now we're rolling along. Okay. So I can add and subtract real numbers. All right. So what are real numbers? Here it goes. On your Freyer model, fill it in the center. Real numbers. Here's the definition. Real numbers are the set of all numbers that can be represented on the real number line. Real numbers, the set of all numbers that can be represented on the real number line. Real numbers, the set of all numbers that can be represented on the real number line. Real numbers, the set of all numbers that can be represented on the real number line. Real numbers, the set of all numbers that can be represented on the real number line. Real numbers, the set of all numbers that can be represented on the real number line. Real numbers, the set of all numbers that can be represented on the real number line. Real numbers, the set of all numbers that can be represented on the real number line. You wrote that already? Yeah. Tell your neighbor the definition. All right, so the set of all numbers that can be represented on the real number line. So think about it. If I was to think of a number that I can represent on the number line, what would my number be? 23, that's right. So guess what? One of those numbers that I give you as an example, yeah, 23 could be on the number line. How about negative 8? Yes. Think about the number line. From here, 0, the positives to the right, negatives to the left. Negative 8 could be placed there. How about 7.25? No. Yes, 7.25 is found between 7 and 8. How about 2/3? Yes, that's found between 0 and 1. So all these numbers could be represented on the real number line. Also, this one, pi. What is pi approximately? 3.14 could also be found on the real number line. So write all these down, please. Okay, so pretty clear. Last year, you were introduced to real numbers, but they broke them down by groups. This year, we're going to do the same, but for right now, I just want to make sure that you understand that it's all the numbers on the real number line. Are we there? Copy this non-example, please. Non-example. As a non-example, I have square root of negative 16. Copy that, please. Square root of negative 16. Square root of negative 16. Okay, so let's find out why square root of negative 16 is not a real number. So let's see. Pens down, pencils down, eyes up here. Here we go. So let me show you an example of a real number using square roots. Check this out. Square root of 4. What square root of 4 says, it says, what number times itself gives me the product of 4? What would be that number? 2. So therefore, this is 2. Is 2 a real number? Yes. So this is true. Okay. How about, let's see, square root of 25. Think about it. What number times itself gives me a product of 25? 5. Yeah, that's 5 times 5. Now, some of you are thinking, also, Mr. Q, can it be another number times itself to give us that same number? Think about it. To give you square root of 25. Think about it. Who thought negative 5 times negative 5? What is negative times a negative? 5 times 5? Okay, so therefore, also negative 5 would be true. And is this a real number? Yes. Yes, could be found on the number line. Okay. So now let's look at this one. What number times itself gives us square root of negative 16? Yes. hold on. He said negative 4, so times itself. What is negative 4 times negative 4? Positive 16, so it's not. Okay. Yes. Okay, I heard negative 4 and positive 4. Are these the same number? No. Yes. You can't. There's no such thing. That's why it's a non-example. These are known. Everybody write this down. Imaginary. These are known as imaginary. Let me move this over. Imaginary. I know, right? All cool? And the symbol for imaginary is this one, an I. Okay? So eventually when you guys get to Algebra 2 and they ask you to find this number, there is such a thing. Square root of negative 16 becomes this. Everybody look up. 4i. Imaginary 4. Everybody see that? Okay? So, now that we got that cleared. So, what is the most important thing to remember about real numbers? They can be where? Found in the real number. So that goes here on the critical attributes. Write that down. All numbers on the real number line. All numbers on the real number line. Okay? So today we're starting with addition and subtraction of real numbers. And this week we were looking at a couple of properties. The properties that we looked at were the following. Once again, a recap. Remember when I made the video that I was going to plant that rosemary bush, right? And I used 0 pairs. We call that the additive inverse property. Also, the other property that we use to represent integers, we use the identity property of addition. Remember those two? Yes, and I also left that for homework. So hopefully you read your notes and you understand where we're going. Okay? However, last year, when you were in pre-algebra, when you guys were adding and subtracting positive and negative numbers, you guys were given a rule using absolute values. Who remembers that? Some of you. Those of you that don't, let me recap for you. Here it goes. Everybody's eyes up there. Here it goes. Last year you did something like this, and here goes the rule. It said, when adding real numbers, if they have the same sign, everybody look up, look at this. You don't have to copy this, just pay attention. Here's this is how it works with the absolute value. Absolute value of 3 is, absolute value of 6 is. If they are the same sign, we add these two numbers, and that gives us 9, and it keeps the sign of both of the numbers, which is a positive. Let me do that with this. Let's see if it works. Absolute value negative 2 is 2. Absolute value negative 9 is 9. Are they the same sign? Yes, they're both negative, so we add them. 9 plus 2 is 11. However, what is the sign of both numbers? Negative. That's how we get that negative 11. Let's see how it works with opposite numbers. Here it goes. Absolute value of negative 8 is 8. Absolute value of 12 is 12. However, since they're not the same sign, we're going to subtract. Before we subtract, I circle the greatest absolute value. So now, 12 minus 8 gives us 4. And what is the sign originally of 12? It was positive, so we get a positive 4. Is it coming back little by little? Okay. Let me show you this one. Absolute value of 3 is 3. Absolute value of negative 15 is 15. Since they're opposite signs, I'm going to subtract, but I need to circle the greatest absolute value. 15 minus 3 gives us 12, but what was the sign originally of the greatest absolute value? It was, that's why this is a negative 12. Everybody see how that works? Okay, so now it's coming back. So what we're going to do today for addition and subtraction, I want you to show me 4 different ways of adding and subtracting. We already know 2, right? Using tiles and the ground zero. This is the third method, and the fourth method will be using the number line. Okay? So copy this down. Example number 1. Example number 1. Copy it under your Ferrer model. Here it goes. Oh, and by the way, let me recap the steps to make sure that this is what we were doing. were we representing whatever they gave us using tiles and symbols? Remember I said, what does this represent? What was the first thing you did? You got your tiles, right? Didn't we do that? Represent it using tiles and symbols. And then what did we do? Find what? 0 pairs, and then at the end we just came up with whatever number it gave us. That's simplification, okay? Subtraction is very similar. I'll get back to that one because there's one more step that it requires. So let's get started really quick with practice. Example number 1. Copy this down, please. Example 1, and write add or subtract using a number line. But in this case, we're going to use all 4 methods. So write that down. Add or subtract using the number line. -3 plus 7. As soon as you copy that, pens down, I'm going to go over all 4 methods so you guys know exactly what we're doing. All right, pens down, eyes up here. So the first 2 methods, here we go. The first method, we see that we can use tiles. So we start with 3 negatives, and then we bring some positives. How many? 7. 1, 2, 3, 4, 5, 6, 7. I circle my 0 pair, and I end up with what? +4. Okay? The other method is the ground 0. Here's the ground. How much of the whole? It's -3. How much dirt? 7. 7. So to fill the hole, we need how many of dirt? Okay, here it goes again. Here's the hole. It's 3. How many of dirt do we need to fill that? If it's a hole of 3, how much dirt do we need to fill the hole? If the hole is 3, how much dirt fits in it? 3. And how much dirt do we have left over? 4. Are we there so far? Okay, don't copy this. You're just paying attention. Third method, using the number line. Here it goes. For the number line, pay attention please. For the number line, we start at 0. And check this out. We start with the first number. What is it? -3. If it's a negative, we go to the left. Because to the left, we find the negatives. Is that correct? And I start at 0. How many steps? 1, 2, 3, and I land at -3. Are we there so far? Next, the second number is indicating us that it's a positive. So instead of going to the left, I'm going to the right from that point. So I go 1, 2, 3, 4, 5, 6, 7. Let's see where I land. This is 1, 2, 3. I land at 4. Everybody there so far? That's method number 3. And method number 4, here it goes. -3 plus 7. I use the absolute value. Here it goes. Absolute value of -3 is 3. Absolute value of 7 is 7. Are they the same sign? No, so I need to subtract, so I circle my greatest absolute value. So what is 7 minus 3? 4. And what is the original sign of this one? Positive, so we're done. Copy that, please. Questions, comments, autographs for this one? We're good? All right, let's move on. Example number 2. Example number 2. Let's see if we can do this one together. It says, add or subtract using the number line, and they give us -4 plus -7. -4 plus -7. Copy that, please, and we're going to do it together. Hurry up. We start off with our tiles. Is that correct? All right, so let's do that. How many negatives? 4. 1, 2, 3, 4. Okay? But then it says add how many more? 7. 1, 2, 3, 4, 5, 6, 7. And next, we need to identify our 0 pairs. Do we have any 0 pairs? No. So therefore, we end up with -11. So was it good? Here's the round 0. Let's do round 0 method. We start with a hole of -4. And do we add any dirt? No. We add another hole of what? -7. So that total should give us what? -11. Is that correct? Everybody see that? Okay. All right. Now that we got that, let's use our number line. Is that kind of crooked? Yeah, right? There it is. Okay. Okay, here's 0. And we start with how many negatives? 4. 4 jumps to the left. 1, 2, 3, 4. We end up at negative 4. So far, so good? Then it says add 7 more, also to the left. 1, 2, 3, 4, 5, 6, 7. Let's see where we land. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 negatives. Did we get the same as this and the same as this? Yes. So far, so good? Yes. All right. And the last method, using the absolute value, negative 4 plus negative 7. Let's see. Absolute value of negative 4, 4. Absolute value negative 7, 7. Are they the same sign? Yes. In this case, we add these two. So 7 plus 4, that's 11. And what is the sign on both of them? Negative. And let me just write a bam. That's what I'm talking about. Piece of cake? Okay? All right. So far, so good? Example number 3. Here we go. See if you can do this one by yourself. Example 3. I want you to copy these two, 3A and 3B, but for right now, I want you to do 3B by yourself, and then we're going to do 3A together. Do 3B by yourself. You should be able to do this one for all 4 methods. 3B. Go. Okay, let's see. So, 3B. You should have done 3B. Is that correct? We start off with tiles. 1, 2, 3, 4, 5, 6, and then 2 more, and that gives us negative 8. Is that correct? Ground 0, we start off with a hole that's negative 6 feet deep. Oh. And then they add 2 more feet, so therefore it's negative 8. So far, so good? From there, we do our number line. And then once again, we start at 0, and then we jump 6 spaces to the left. 1, 2, 3, 4, 5, 6. We end up at negative 6, and then 2 more. 1, 2. So therefore, we end up at negative 8. So far, so good? And the last one, using the absolute value, I'm just going to use it here. Absolute value negative 6 is 6. Absolute value negative 2 is 2. Since they're the same sign, we add. So this is 8. Oh. And what is the sign for both of them? A negative. So this is negative 8. So far, so good? All right. So now let's do this one together. Some of you are saying, oh my goodness, fractions. But check this out. If I was to use this method, a cover-up method, first of all, do we have a common denominator? Okay, let me cover the denominator really quick. What do you see? Negative 3 plus 1. So what you can do for your fraction to get organized, check this out. You draw your fraction bar, and then we have negative 3. Oh, sorry. 3 negatives. 1, 2. Oh my goodness. 1, 2, 3, and 1 positive. Is that correct? Yeah. We eliminate our 0 pair. There it is. And we end up with negative 2. Is that correct? And what was the denominator? 4. So now you just bring this over. And we can simplify. This is negative 1/2. Bam. Copy that, please. Next method, using the ground 0. So for the ground 0, I'm just going to focus on the numerator. Here it is. Ground 0 is right here. We have 3 negatives, 1 positive. And what does that give us? Negative 2. And what's my denominator? 4. And it still gives us negative 1/2. Piece of cake? Yeah? Next method. Here goes the next one. This is the challenging one. That's why I wanted to do this one with you. Here it goes. Let me move this out of the way. All right. Here goes my number line. Here it goes. Draw your number line. Everybody look up. There it is. Okay? Now, we said that at the beginning of the year, I said, guys, last year, when you guys worked with proper fractions, that was less than what number? 1. Remember that? Are these proper fractions? Yes, so that means they're less than 1. So that means I'm going to do this. Everybody look up. 0. I do a big space and 1 negative, a big space and 1 positive. Everybody see what we did? Since we are not going farther than that, that's where we just draw negative 1 and 1. So now, let's look at the denominator. We need to divide it into how many sections? 4. Check this out. This is the easiest way. Look at this one. I go half, and then half of each half. Let me do it right here. Half, and then half of each half. Piece of cake? Okay, do that, please, and then we'll do the jumps. Okay, let's do the jumps together. We start with, let me get my computer to react. Okay, there it is. How many negatives? 3/4. So I start at 0, and each one of these is a fourth. So how many jumps? 1, 2, 3, and I land at negative 3/4. See how that works? But then it says add 1 positive fourth. So I jump how many times? To the right, because it's a positive. So I end up at negative 2/4, which becomes negative 1/2. So easy, right? And the last method, using the absolute value, here we go. We got negative 3/4 plus 1/4. Let's see. Absolute value of negative 3/4 is 3/4. Absolute value of 1/4 is 1/4. Are they the same sign, the numerators? No, so we circle the greatest absolute value and subtract. What is 3 minus 1? 2. Carry over the denominator. And what is the sign of the biggest absolute value? Negative, and we simplify that to negative 1. Bam. So far, so good? All right. Example number 4. Here we go. For those two, I want you to solve them, simplify them, add them, using any method. Using any method. Yeah, just one method. So pick a method and add this one, and pick a method and add that one. Go. You got 40 seconds. For 4A, using your method, you should have gotten negative 12. Hands if you got that. Okay. Same thing for B. Any method you use, you should have gotten negative 35.8. Okay. Good job. Okay. So now, before we move on, let me move on to subtraction. Notice that we've been doing only addition. Subtraction. So here we go. Pay attention. Okay, for subtraction, there's one thing that we just need to change, and it's using the additive inverse property. So check this out. If I was to show you this, just pay attention. You don't need to copy it right now. Check this out. By using the additive inverse property, the additive inverse property says, actually before I get to this one, let me show you this. Watch. 7 minus 4. What is 7 minus 4? 3. Okay. However, the additive inverse property says additive inverse. So I add instead of subtract. And what is the inverse of a positive? Negative 4. The first one stays the same. Do we know how to do these? Yes, we got 7 positives, 4 negatives, and we end up with 3. But what did I do? I changed this to a positive and this one to its opposite. So the only thing you need to remember for subtraction, you add the opposite of the second. So let me show you with that example that I just showed you. Pens down and eyes up here. Here it goes. Watch. This stays the same. I change this to addition. And what is the opposite of a negative 4? 4. So what is 5 plus 4? 9. If you want to use tiles, you can show it with tiles, and you can just do that. But the only rule that you need to remember is add the opposite of the second to the first. Copy that, please. Copy this example and copy the rule. Because if you know this rule, you go back to addition. Are we experts at addition now? Yeah, because we know all 4 different methods. Yes. Keep, change, change. Okay? Yeah, I like that. So some of your teachers showed you keep, change, change. That's fine. Okay? Yeah. Keep the first. Keep the first. Change the sign and change this the number of. Yeah. Everybody got it? Any questions on subtraction? So basically, subtraction becomes what? Addition. And do we know how to do addition? Yes. So for homework is found on page 17, numbers 1 through 23, all. And I also want you to read the section of the lesson 1-2, which is this one, adding and subtracting real numbers. It's 1-2. Read it. Understand the example for the word problem, which is all. The only thing is the setup. Okay. Any questions? No. Yes. Yeah. Yeah, that could be also. All right. Have a good one, guys. Enjoy your homework. I'll see you guys on Tuesday.